how to do that. First, you might get the a lot of data, but I think it's very unlikely that you need to calculate the all this data. For example, to sum all that data up and to calculate the average is very unlikely for you to do that. So I think you might get the processed data, but still raw data. So you might get a sum. So if there is x and there is the y here, you might get the sum of x and the sum of y. Okay, and once you got the sum, you can calculate the average. So let me just use the average, AVG, average here. So once you got sum, you got all these numbers. So if the number is n, you can easily calculate the average number here. And of course, once you got all the sum and all this average, let me add a little I here. So we have a lot of x and a lot of y. Okay, so once you got x and got y, you can calculate the average of x and average of y. So you kind of can calculate this, that this is x. If I add overline above x and overline above y, we get the mean of x and mean of y. Okay, once you got that and you compare every individual x and individual y with the average x and average y, you got the deviation from the mean. Okay, and once you got every deviation, you square that, you sum that, you got the sum of square deviation of from the mean. Okay, so let me just give you the steps of how to calculate. This is step 1. This is step 2. Step 1 is just give you the sum. Step 2 is to calculate the average. Let me just use the mathematical notation here. Introduce a little healthy amount of math is good for your health. Okay, so if you calculate the sum, this is the summation notation. So I equals to 1 and all the way up to m. That is the summation of x. So x, I, that is the summation of it. And of course, we can also use this notation, mathematical notation, and to add all y. And of course, you can sort of use this summation and you divide by the number that you are using right now. For example, the n. Okay, once you divide that, and you kind of got the average, of course. And of course, you sometimes need to worry about the degree of freedom. I'm going to talk about that at the variance and covariance, and of course the standard deviations calculation. So don't worry about it. I will write all that down. So at the exam, you might encounter the semi-product, which means that it kind of gives you the processed data, but not the final product of it. So you might get the sum of squared deviation from the mean. So I think my requirement for you guys is to understand if you encounter these requirements, these descriptions of data by full English or by mathematical notation. You need to understand what is going on here. Okay, so let me just write that for you. If there is sum of square deviation from the mean, so first you need to calculate the deviation from the mean. Okay, so how to do that? So this is the mean. If you add an overline over x, that is the mean of x. And of course, every certain xi, we can calculate for every xi, you can calculate the deviation from the mean. You just subtract that, and that will give you a deviation from the mean. Okay, and you kind of need to square that, so you can square that. That is square. Okay, and the final thing is just to sum all of that. So you need to add a mathematical equation, and r equals 1 all the way up to n. So that is the sum of the square deviation from the mean. Okay, and you can also use the same method, I equals to 1 all the way up to n, and use the yi minus, y over line, which means that is the mean of y. And of course, you can square that and you can sum all that up, or you got the sum of a square deviation from the mean of y. And once you got that, you can calculate the variance of x and variance of y. And of course, you square the variance, you got the standard deviation of x and y. So fairly simple. So you might get this data, but still is the data you need to process. So you can calculate the standard deviation or variance. I think you can calculate the variance first and then standard deviation. So let me just use this data. And how to calculate the variance, you just need to divide that by n minus 1, because this is considered the degree of freedom. All right. Once you got that, you need to calculate the standard. So once you add standard here, you need to square that. That is the standard, right? And you can use the same method, n minus 1, and you square root that. So you got the standard deviation. All right, so that's pretty much all you can do. And of course, you sometimes got the cross product of it. So what is the cross product? Cross products just you cross that and you get the product of it. So you got xi and subtract by average of x, and you got yi and subtract by average of y, and you sum all that up from all the way I equals to 1 to n. And that is the cross product of it. So let me just write all that down. Cross product. Cross products of the deviation from the mean. So that is still the semi-product of it. You need to calculate the covariance, of course. So you use this data, and let me add one more step. You use this data, and you still don't calculate the covariance, because you just sum all that up. You need to consider the number here. So what we need to do is to divide by n minus 1. So that, of course, just consider the degree of freedom. And once you got that, you got the covariance. So once you got the covariance and the variance of it, you can just use or combine these two together. You can got the covariance of x and y, and there is always the standard deviation of x, the standard deviation of y. So this is very important. You might need that. So I think this probably is very familiar to you, but this is calculation of it. So you might get asked how to calculate covariance of x, y, how to calculate the standard deviation of x and standard deviation of y. And that's how it is done. We have written that the left side of it, so you know how it is done. Right, so that's pretty much the way we deal with this problem.